right, guys, here we go. So I asked you to graph these two lines on the same coordinate plane. Right now, everybody in this class knows two different ways to graph a line. You could put the equation in slope-intercept form, use your slope, use your y-intercept. I love it because when you have that slope, you can create as many dots as you want. Or you now know that you can find the x-intercept and you can find the y-intercept, connect those two dots, and graph a line that way. That is usually recommended if the equation is in standard form and you don't feel like converting it to slope-intercept. But lucky for us, every single one of these equations was already in what form? Slope-intercept, right? So you know your slope and you know your y-intercept. So graphing should be really, really fast. All right, if we graph the first line, who is his slope? 1/2. And who is his y-intercept? So we start there. So we go down 5 to where he crosses over the y-axis, and then we're going to use the slope rise over run to move. So we're going to rise up 1, and we're going to run to the right 2. Up 1, right 2. And we're going to keep doing it and for as long as we want. I can also go the other way by doing the exact opposite and going down 1 and left 2. Perfect. Connect your dots in the straightest line possible, and there's the graph of that line. All right, now we graph this line. His slope is also who? 1/2, and his y-intercept is 3. So we're going to start at a y-intercept of 3. X is 0, y is 3, right there on the y-axis. And again, we're going to rise up 1 and run to the right 2. Okay, connect them. And we're good to go. All right, guys, looking at those two lines, does it look like they are ever going to cross over and meet? No. So lines that never meet are called what kind of lines? These are parallel lines. They are never going to cross over and intersect one another. Does anybody know why they end up being parallel lines? Because they have the exact same slope. And that's exactly why lines are called parallel. It's because they have the exact same slope. They have the exact same rate of change. They are moving at the same speed, if you will. Think about it. If you are in your car and your friend is in that car, if I start here and somebody else starts at the back of the classroom and we take off in the same direction, but we go at the same speed, am I ever going to catch up and catch that car? No, because we're moving at the same speed. Parallel lines start in two different spots, but they grow at the exact same rate. So they're never going to cross over and meet one another. This line would have to move at a faster rate in order to catch up, meet, and cross over it. So the reason lines end up being parallel is because they have the exact same speed. They have the same rate of change. They have the same slope. So today, I need to go over that with you so that we can use it in the next section. You have to remember what it means to be parallel. All right, and then if you're not parallel, then you might end up being this. So if we graph these lines, this one has a slope of 3/2 and a y-intercept of 4. So we go up 4, and then we can rise up 3 and run to the right 2. Oh, I didn't do it. Down 3 and left 2 the other way. And there's our perfect. I'm trying to make them as straight as possible. Looking good. Looking good. I'm feeling pretty good. All right, and then this one has a slope of -2/3, and I always give the negative to the top number and keep the bottom number positive. Just don't give it to both, because a negative over a negative isn't negative. And then it has a y-intercept of -2. So now we're starting down here. I'm going to rise down 2, and I'm going to run to the right 3. Or I can do the opposite and go up 2 and left 3. All right, and then if I connect them as, I missed it. Okay. Either way, these lines definitely meet, and you're never allowed to assume it, but I'm going to ask you guys today to assume it. It looks like, they're meeting at what kind of an angle? Oh, that's not the angle. What kind of an angle are they meeting at?
90.
Nope, a 90-degree angle. They're meeting at that beautiful right angle. And that's what it means to be perpendicular. Perpendicular, they are lines that definitely meet, but they meet in a very specific way. They meet and they form a 90-degree angle. Now, you're not allowed to assume a 90-degree angle unless they put the little right angle symbol there. I know that these are definitely perpendicular lines and they are meeting at a right angle because perpendicular lines, their slopes are not the same. This one is 3/2. This one is -2/3. They're not the same, but they are the opposite sign. One is positive and one is negative, and they are what we call reciprocal. He's 3/2. He's 2/3. They are the same fraction, but flipped over. And that's exactly what happens when lines are perpendicular. They meet at this 90-degree angle because the opposite is going on. He's positive, he's negative. He's got a rise of 3, he's got a run of 3. He's got a run of 2, he's got a rise of 2. They have the exact opposite going on, and it forces them to meet at this 90-degree angle. So that's what happens when lines are perpendicular. Their slopes are opposite sign and reciprocal. And hopefully you remember that from geometry. And that's what I'm going to review with you today. To be perpendicular and to be parallel means that their slopes have to be two very specific things. All right, so let me give you your notes. And again, the reason I want to review this is because after our quiz, we start section 4. Section 4 is going to make you guys write the equation of a line. They're going to give you clues about the line, and then they're going to ask you to come up with his y equals mx plus b, his equation. And some of the clues they give you are parallel and perpendicular. And you have to know what are they telling you by telling you something is parallel or perpendicular. All right? So on your notes, let's fill in the definitions first, and then we will practice some problems. All right, so what do we say? If lines are parallel, then these are lines that never intersect. Right? They never intersect, they never meet, they never cross over. And the reason that parallel lines will never intersect is because what are their slopes? They're exactly the same. They're moving at the same speed, but they started in different spots. Okay, they are equal. Just be careful. On Delta Math, they're going to ask you questions tonight like, oh, are the lines parallel, perpendicular, or neither? And they're going to set you up to trap you. They're going to give you the equation of a line and the equation of another line, and they're going to have the same slope. And you're going to be like, oh my God, this is so easy, it's parallel. But be careful. Parallel lines have to have the same slope, but different y-intercepts. They have to start at a different spot and then move at the same rate. On Delta Math, they're going to give you the equation of a line, and then they're going to give you the equation of the exact same line. And they're going to ask you if they're parallel, perpendicular, or neither. And the answer is neither, because if they have the same slope and the same y-intercept, then guys, they're the exact same line, and they have every single point in common. But you guys are going to be moving so fast, go on and get your homework over with, all you're going to see is the same slope, and you're going to put parallel. But make sure that if they are parallel, it's because the slope is the same, but the y-intercept is different. So watch out for that. All right, perpendicular lines. These are lines that definitely meet, and they meet very specifically at a 90-degree angle. Right, they form that right angle at their intersection, which you are never allowed to assume. You can never look at two lines and go, yeah, it looks like it's a right angle. No, they either have to put that little right angle symbol, or you have to prove that they are perpendicular because their slopes are two things. One is positive and one is negative, so they have to be opposite sign as each other. And they have to be that reciprocal. They have to be the same fraction, but flipped over. And that's how you'll know that these are definitely perpendicular lines. So guys, whenever the word parallel or perpendicular is mentioned, it is automatically a slope question. That is what we are talking about when we mention parallel and perpendicular. It has everything to do with slope. These are going to be slope questions. All right, and then just to give you another way for telling perpendicular, because a lot of math books will mention this, so I want you guys to know. If one slope was 2/3, then the perpendicular slope would have to be negative, the opposite sign, and the reciprocal. So if that's true about all perpendicular lines, then it's also true that perpendicular slopes, when you multiply them together, they always equal -1. So what's 2 times -3 on top? -6 over what's 3 times 2 on bottom? And what is that going to divide to equal? Perpendicular slopes will always have a product, will always multiply to -1. So that's just another way that sometimes folks will tell you to prove perpendicular lines. Prove that their slopes multiply to -1. So I can also say that the slope of one line, M1, times the slope of a second line, M2, it'll always equal -1 if those slopes are perpendicular. Okay, I just want you to remember that in case it helps in the future. All right. First example, guys, I am not trying to trick you. These answers are extremely obvious, but let's do it. Find the slope of a line that is parallel to a line with the given slope. So guys, if one line had a slope of -3/5, then what would the slope of a parallel line have to be? Exactly, -3/5. It has to be exactly the same. So if one line had a slope of 2, then what would a parallel line's slope have to be? 2. So in the future, if you have to write the equation of a line that is parallel to a given line, they are telling you use the same slope as that line. They are giving you a clue about his slope, because the minute parallel and perpendicular are mentioned, it's a slope question. All right, if one line has a slope of 0, then what does the slope of a parallel line have to be? 0, nice and easy. Okay, perpendicular. Find the slope of a line that is perpendicular to a line with a given slope. If one line has a slope of, and don't mind my blue, it's all my spaces on my Word document. If one line has a slope of 3/4, then what would a perpendicular line's slope have to be? And it would have to be negative. So -4/3. Make it the opposite sign and flip it over. All right, if one line has a slope of -5, now again, slope should be a fraction. We can make -5 a fraction real quick by putting it over 1. So if that is the slope of one line, then what would a perpendicular line's slope have to be? Positive 1/5. Opposite sign and flip it over. And then here, I threw a little bit of a curveball. Here we go. If one line has a slope that is undefined, now think about how you get an undefined slope. Slope is a fraction with a top number and a bottom number. Who are you not allowed to divide by in math? And where would that be then when you try it on the bottom? So an undefined slope would look like this. Some number divided by 0. So a perpendicular slope would be the reciprocal, and it would be the opposite sign. So guys, what's 0 divided by any number in this world? 0. So the perpendicular slope to undefined is 0. And vice versa. If you were given a 0 slope and they asked you for the perpendicular slope, then the answer would be undefined. All right, now let's visualize this. Does anybody know what a line with an undefined slope looked like? Vertical, up and down. Guys, what would be the only kind of line that could be perpendicular to a vertical line? It's got to be a horizontal line. And what was the slope of a horizontal line? 0. So keep that in mind, right? He was your undefined slope, and he was your 0 slope. All right, perfect. All right, next example. All right, so in example 3, they want you to determine if the following lines are parallel, perpendicular, or neither. Guys, if you're going to find out if lines are parallel or perpendicular, what piece of information do you have to know about those lines? Gotta know their slope. These are slope questions. If you want to talk about something being parallel or something being perpendicular, then the piece of information you need is slope. So they are telling you that line 1 goes through these 2 points, and line 2 passes through these 2 points. We have to find out what these lines are, parallel or perpendicular or neither. So again, if I'm going to answer this, what do I have to find? Slope, and they've given you 2 points. So you can calculate each line's slope by finding change in y over change in x. We just took a quiz on this. All right, so let's do it. Let's find the slope of line 1. I'm going to call it M1. Let's see what we get. Change in y over change in x. So I'm going to start with this y coordinate, -1. I'm going to find the change. So how do we find change? What operation? Subtract. What's the next y coordinate? Just 2. Over change in x. Now in the same order, we have to subtract our x coordinates. So I'm going to start with this x. I'm going to find the change, so I'm going to subtract. What's the next x? -2. Guys, what happens when you minus a -2? Plus. So slope always starts as subtraction, but it might turn into addition when you subtract a negative number. All right, we're going to get what? -3 over +2. It doesn't reduce, so we're good. That's his slope. All right, now let's find the slope of the second line by doing the exact same thing, so it's tedious. And we're going to find the change in y over the change in x again. So I'm going to do the same thing. Take this y coordinate, 3. I'm going to find the change, so I'm going to subtract the next y coordinate, which is -1. What happens when you minus -1? Turns to plus. All right? Over, now in the same order, find the change in x. I'm going to take 2. I'm going to find the change and subtract. The next x is -4. What happens to minus -4? Plus, we get 4 over 6. Now, guys, we're not going to look at that being like, oh, look, it's neither, because we know that slope is a fraction, and what do you always do to your fractions? You better reduce, because you might miss something that matches. And it both divides by 2, so we end up with 2/3. All right, so his slope was -3/2. His slope was 2/3. Who can you definitely rule out? They ain't parallel. These are not the same slope. Could it be perpendicular? Are they opposite side and reciprocal? Boom, perpendicular lines. Okay, I want you guys to do the second one. Find me the slope of line 1, find me the slope of line 2, and then let's figure out if they're parallel, perpendicular, or neither. I'm going to give you like a 15-second head start. Just be careful. Don't let your eyes play tricks on you. Make sure you're taking a Y with a Y and an X with an X. What you got? Yep. Do you have your pass or do you need me to write you one? Wait for me. Compare your slopes with mine. What are we thinking number 2 is, or B, whatever we're on? Parallel. Guys, I got the exact same slope. I got -5/3 for both. But guys, everybody look up here. I don't want to make any silly mistakes. If somebody got this, and then you got this on your next one, and I'm not trying to trick you, are they the exact same slope? Yeah. Yeah. Who cares who has the negative sign, guys? At the end of the day, it's this. It's -5/3. It's a negative fraction. It don't matter who gets that negative sign. Give it to the top, give it to the bottom, just don't give it to both. So please don't be like, oh man, so close, but they're not the same. Yes, they are. All right, do the last one. Find me the slopes, and let's figure out what these ones. Guys, they are trying to trick you on the last one. Don't fall for it. You're better than that. Steven, I swear to God, if you fall for this.
I hope not. I don't understand. What do you mean trying to trick us?
Maybe I didn't get you, Darren. Maybe you're too good. Andre, I'm good when you are. Yeah.
Is this right? The last one?
Hold on, wait for me. Maybe you weren't even thinking it's even, and now I screwed you up. Darian!
They got me? Yo!
Oh, I almost made it with my left hand.
Why'd they get me for it?
What signs did you get?
I think, opposite.
Did you? No. Bianca, redeem him.
I don't know.
No! What sign is that? What sign is that? And what do?
Oh, I should cause it.
I got it.
Come on!
Wow.
So
Oh, wait.
it's neither.
Ooh, wait for me.
I don't understand.
Hold on, wait for me.
No, I don't get there. I'm not getting it.
You did your thing.
I got one. The top one.
I think I'm right.
Yeah, that's what I got.
All right, so my slopes,
Oh, that's why.
I got -7/8,
Yeah.
and then I got -8/7. However, they are expecting you to be like, oh my God, they're reciprocals, it's perpendicular. But they're both what sign? So you can't fall for that. I don't even look for reciprocal. The first thing I check is make sure one's positive, one's negative. Make sure you have the opposite sign, and then you can go for the reciprocal. This one, I think our eyes just play tricks on us, and we just see the reciprocal, and we automatically think, oh, perpendicular. But they're the same sign. They're both negative. One slope would have to be positive, and one slope would have to be negative in order to be perpendicular. So these are neither. And guys, this used to be a written quiz question, and I'm telling you right now, it would be like 50-50. Half the class would get it right, and half the class would get it wrong. So you are not alone if you were thinking perpendicular. All right, last example on the back.
Do we have to solve all of them?
Well, I'm going to do it with you because,
I don't understand.
yes, you do. We are going to circle the pair of equations that represent parallel lines. We're going to put a box around the pair of equations that represent perpendicular lines, and then we're going to put an X over the ones that are neither. Guys, if we're going to start talking about parallel and perpendicular lines, what piece of information must we need? Yeah, slope. And if you want to look at the equation of a line and find out who his slope is, what form does your equation have to be in?
Why?
It's got to be in slope-intercept form. We need y equals mx plus b form. All right, well, the good news is, guys, the first equation in every single pair is already in what form? It's already in slope-intercept form, so we're good. So it's only the second equation that we got to mess with. So, guys, if I want to know his slope, I got to solve it for y. So what are we going to do first? Subtract 3x, get it out of there. I'm going to get positive 4y's equals negative 3x plus 8. The only thing we got left to do it. So I get y equals negative 3/4 x, does not divide, does not reduce, and then plus 2. All right, so what is the slope of the first line that we didn't even have to touch? 3/4. What's the slope of the line that we just found? They're clearly not what? Parallel, they ain't the same. Are they opposite sign and reciprocal? So these are neither, put an X through.
Oh. I didn't know it didn't.
All right, next set. Guys, first equation, man, he's beautiful, he's good to go. We already know who's his slope. The close, the -2. So now let's get this y by himself so we know who the second line is. Guys, this ain't bad. All we got to do is get that 2x out of there, and then y will be by itself. And then we get y equals negative 2x plus 7. Who's the slope of the line you just found? Ooh, baby. So guys, it looks like they're parallel, but we're not going to fall for anything. The first you're going to do is you're just going to check that they're not the exact same line. They both have a slope of -2, but are their y-intercepts different? Yeah. So we're okay. So then these are definitely parallel. So what we're doing, a circle.
Parallel? What? I thought you said they're both negative. It's negative.
What?
You said
I said no such thing.
Before they were like reciprocal, except
They have
both negative.
Parallel have to be the exact same number. Perpendicular have to be two things: opposite sign and reciprocal. So the last example was like -7/8 and -8/7. They weren't the same, so it's not parallel, and they weren't the opposite sign. They were both negative slopes, so they were neither. These are exactly the same slope, and that makes them parallel. All right, last one. First one is beautiful. Guys, don't touch them. Solve that bottom one for y, which we have been training for months. -2y equals -8x minus 10. All I have to do, divide that -2 out of there. Make sure you divide and reduce everything. And you get y equals, what's -8 divided by -2? 4x and then plus 5. All right, who's the slope of the line we didn't have to touch? Nice. And who's our slope down here? 4. Clearly they ain't parallel. They are not the same. But are they the opposite sign and reciprocal? We got ourselves perpendicular, so we're putting a box. Yep. All right, give me 1 minute. All right, guys, I always freak out about this, so I always feel bad showing you this first so that nobody goes home and wastes a second of your time trying to figure anything out on your own. So can I just show you one thing on Delta Math so that nobody goes home saying, Hardy, what the heck is this? All right, so on Delta Math, your homework tonight is not due until Sunday night. So I give you all weekend to get it done. I think it's 15 questions, pretty quick. All right, watch this. This is one section of problems. All right, here we go.
Oh, wait.
All right, so everybody look up here. Okay, I think you have maybe 3 or 4 of these to do, maybe 5. They're going to give you an already graphed line in blue. The directions above say this. Graph a line that is parallel to the given line. It'll either say parallel or perpendicular. Graph a line that is parallel to the given line. Determine the slope of the given line. So you have to find the slope of the blue line. And then you have to find the slope of the, determine the slope of the given line and the one you graphed in simplest form. So you have to find the slope of the blue and then the one you graphed and type it in. So guys, this is all you have to do. To graph the parallel line, move your mouse somewhere on the coordinate plane. I'm putting it at 3, 3. Click and hold. Once you click and hold, a yellow dot appears, and then you just start rotating. Guys, all you gotta do is spin your mouse and move the point like up and down. Watch this. I don't know if you saw it, but if I go, boom, see the green line? It automatically appears. However, would you say that's a parallel line? No, that would be the answer if they asked for a perpendicular line. But they didn't ask for that. They asked for a parallel. So keep spinning your mouse. And sometimes you have to move the point up and down until you get a green parallel line to appear. And then let go. That's all you have to do. Okay? And then we're going to go down. And they asked for the original slope, which is the blue line, and the parallel slope, which is the green line. So guys, we are stuck with that. They don't give you the dots. So you got to find good points like great point, no, great point. So we have to go down 1 and right 2. So -1 over 2. That would be your original slope. So plug it in because that's the blue line. But guys, if the green line's parallel, who's his slope too? -1 half. Type it in and get your green check. So I didn't want anybody freaking out about like, what do you mean graph the line? Because I learned these things slow. Let me show you this really quick. Because you're doing so wonderful. All right, same thing. Shut up, Chris. That's a horizontal line. The directions said, you can't see it, it asks for a perpendicular line. Who's the only kind of line perpendicular to a horizontal? So click and start rotating until you get a green vertical line. All right, what is the slope of a horizontal line always going to be? 0, right? Look, there's no rise, so the rise is 0 and the run is crazy, so it's 0. And then what is the perpendicular slope, opposite reciprocal to 0?
Undefined.
Undefined.
I have a question.
Yes.
How do you know where to put your first dot?
Anywhere. Click anywhere, and then you're just going to spin your mouse, and you might have to move the yellow dot like up and down until that green parallel or perpendicular line appears. But it shouldn't matter where you put the first click. I kind of go somewhere near the origin. And then you hit submit and you're done. So again, I feel better having shown you that, so hopefully that's not something you have to play around with for a few minutes before you get the hang of it. Now you know what it looks like. The other homework questions are much more self-explanatory. It's just literally parallel, perpendicular, or neither by looking at an equation or a graph. Okay? Yes? Yeah. So guys, you have 9 minutes. You could probably get a nice chunk done if you have your Chromebook and you get started. Otherwise, this is due Sunday by 11:45. And please bring your Chromebooks Monday so we can review, and bring them again on Tuesday so we can quiz.
Are we gonna play that game again sometime?
Absolutely. Dude, I could not stop smiling yesterday. I was so happy with that game. I'm playing next time, though. What I want to do, hold on, I gotta stop the video.